Naming organic molecules is not a skill that serves in very many places, but being able to interpret the names and change them into structures, that's a skill you can use at least throughout all of this course and can often help you in understanding organic molecules when you encounter them in other settings. So this video, we're just going to practice making the names, turning the names into structures. Start at the end. Hex tells me I'm going to have 6 carbons. Ene tells me I'm going to have a double bond somewhere. The double bond's going to be at the 3rd position. So I got 1, 2, 3. That's where it's going to start. So it's going to go double bond to 4. And then we'll go 5, 6. We've got a methyl group at 3. 1, 2, 3. Add the methyl group. Now this could be one of 2 isomers. If I'd done something like this instead, then we would have the big groups opposite each other here, trans, from there to there, and the big groups on the same side here, or cis. Let's go to the next structure. We'll move on to the second. We go to the end again, heptene, and you look that up if you don't remember, but that means 7. Ene means a double bond. The double bond starts at 1. So I'm just going to draw it right off at the beginning from 1 to 2. Then I go 2 to 3, 4, 5, 6, and 7. Can't be cis or trans because it's got 2 H's here on the end. Now we start adding groups. 5 methyl, 2, 3, 4, 5. There's a methyl group. 3 ethyl, our 3 was here. And we're done. Let's go to the next one. Go to the end, pentene. That's 5 carbons. It doesn't tell us where the ene is. But here it's cyclopentene. So when you're naming a ring, wherever you put the double bond defines 1 and 2. So it's either 1, 2, or 1, 2. At this point, it doesn't matter. So I'm going to go from the top one, 1 to 2. Here's my cyclopentene. Now I've got to add dimethyl, so 2 methyl groups, and they are at 1 and 4. Well, I called this 1. I'm going to count from 1 to 2, 3, 4. That gives the lowest numbering for these 2 methyl groups. Moving on to our 4th molecule. 5,6-dimethyl 2-decyne. Dec tells me I've got 10. Ine tells me I have a triple bond. And the 2 tells me where that triple bond is. So I'm actually going to draw the triple bond first. It starts at 2 and goes to 3. So it starts at carbon 2, goes to carbon 3. So that means there's got to be a carbon 1 off of it. There's my 1. I'm going to continue on. 4, 5, 6, 7, 8, 9, 10. And at 5 and 6, I have to place methyl groups. So 3, 4, 5, and 6. Methyl, methyl. 2,4-heptadiene. Hepta tells us 7 again. Diene tells us we have 2 double bonds. So I could just go like 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And then I count to 2, draw a double bond, 3, 4, double bond to 5, 6, 7. In this case, both of these are trans. So I've only drawn one option of this. I could make the first one cis. I'll do that like this. So this is trans. Now this one here, with the 2 big groups on the same side of this double bond, gives me cis trans. And I've got 2 more ways I could draw it. I could draw them both cis. There's the first one cis. The second one cis. And I've done 1, 2, 3, 4, 5, 6, 7 carbons. And I could swap these 2. Let me label this first. Cis, comma, cis. And here I could swap these 2 and do trans and then cis. Let's see, 1, 2, 3, 4, 5, 6, 7. And this time I have trans, comma, cis. So this name is ambiguous until we include the stereochemistry. Let's move to the 6th one. Trans 2-butene. Start with the but, that means it's got 4. Ene tells us there's a double bond at 2. Well, I'll draw that, 2 to 3. It's got 2 to 3. I've got to go to 1 some direction. I could either go up or down here. Let's go down. Okay, it has to be trans. That means if this one's down, this one has to be up. Now I've completed 1, 2, 3, 4. There's the butene, the but, there's the ene, and down and up is the trans. I'm going to do one more. Cis 3-methyl-2-hexene. I'll draw it above it. Start with the hexene. It's got an ene at 2. From 2 to 3. My first one I can draw either direction. So I go 1, 2, 3. I look out front, it tells me it's cis. So going to 4 is going to go the same side, both of them up in this case. And then we go 5 and 6. The methyl group is at carbon 3. 1, 2, 3. Here it may look like it goes up and then down, so that's trans, but this is bigger, so we go up, up to the bigger side. That makes it cis.